With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us try to solve the given problem. So the given problem simply states an open pan P filled with water of density rho W is placed on a vertical rod. So we have a pan P here and it is placed on a vertical rod maintaining equilibrium. Now this pan maintains the equilibrium. The block of density rho is placed on one side of the pan. So we can see a block here, its density is rho and it is placed on one side of the pan as shown. The water depth is more than the height of the block. Now the total depth of the water here is simply more than this depth or height of this block. Then we have been given four options here. We have to check which of the following option is correct. So let us draw a simple diagram for better understanding. So you can see that I have redrawn this diagram. Now this pan is simply balanced about this point. Let us call this point as F. And you can see that this can only remain in equilibrium, right? If we take any two corresponding points here, let us say this is point here and this is point here. Let us take this as A and this as B. So this can remain in equilibrium only if the pressure at A is simply equals to pressure at B. If it is not so, the pressure any side is simply more, then that side will simply tilt and this pan will not remain in equilibrium. Now let us try to see how can this be maintained. Let us say that the total depth of the water filled here is simply small h, and let us say that the depth here is simply d. So you can see that the pressure will be simply, pressure at A will be simply equals to pressure at B if this block is not touching the point B, right? Why? Because if this block touches at point B, then what will happen is that the pressure at A will be simply rho gh. So you can see that if it was touching, then the pressure at A would be simply rho g into small h. And if this block was touching, then the pressure at B would be simply nothing but it will be rho gh plus the weight of this block. Now here you can see that clearly the PB would be more and this would tilt on this side. So the condition for which this block to remain in equilibrium is that this block should float in water like this, and it will float in this liquid like this only when its density is simply less than or equals to the density of the liquid. Now which makes this as the correct option. Now why we can see here why that these two conditions will be satisfied. We can see that the body floats when the density of the body is less than density of the liquid, then the body simply floats with some part of it above the water, right? Just like this. And if the density of the body simply equals to the density of the water or the liquid, then the body simply floats like this, just below the surface of water. Body just floats like this below the surface of water. So you can see that in both the condition, what will happen is that in both the condition, these two condition, the block will not touch this point and there will be no excess pressure here. So the pan will remain in equilibrium. So this is the condition that pan will remain in equilibrium and B will be the correct option. I hope you understood the entire explanation. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.